works? Yeah. Definitely? Okay. Why? Okay, let's do something very simple example. Do I get the same answers if I add these together and then multiply, or if I multiply separate and then add together? Same answers. So I'm going to do the distributive rule, multiply 6 times 2 and 6 times 1, then add. And I'm going to do another time, add 2 plus 1 and then multiply by 6. And see if we get the same answer. So let's do the distributive rule, which is distribute this multiplication across the bracket. So 6 times 2 gives 12, and 6 times 1 gives 6, and I'm going to add those together to give 18. The other way of doing it is then do what's in the bracket first, 6 bracket 2 plus 1, which is 3, and then do the multiplication, and we get 18. So it does work. It works both ways. It always follows. And the reason we just can't do the bracket first is what in this case? Yeah, they're not the same terms. One has an x and one, like this says 3 apples and $1, if you want to think about it that way. They're not the same terms, so they cannot be just combined. This doesn't make 4x together. So I can't combine it, but I want to apply the multiplication without combining. And that's the distributive rule. Distribute the multiplication across the two. So this is twice this. There's, of course, 2 ways of doing this. The really slow way, write this down twice. 3x plus 1 plus 3x plus 1, which is the slow way. 6x plus 2. Or what most of you are well used to doing is multiply by 2, and we get 6x plus 2, the fast way. Yep. So you probably have never done that, but that's writing that down twice and putting it together. Because you just go to this. 2 times 3x is 6x, and 2 times 1 is 2. But this is what you're really doing. It's 2 groups of this. That's what you've done. Okay. Let's go through some of the examples that are on the board now. That's the basics of it. Let's look at a b. What happens if there's an x outside the bracket? If we get something like this, 2x times this. Well, it's the same. I'm going to go straight to this answer now. This times this gives 10x, and this times this gives what? Negative 4x squared, yes. X times x gives x squared. Very good. Okay. The tricky thing happens when we start to deal with multiple of these multiplications and we have to combine them into one simplification. That can be a little bit tricky, especially if there's a negative involved. So I'm going to look at the 2 examples that we have to do that. So if I have 2 times 3x minus 1 plus 3 times 5x minus x. So expand and simplify is the mathematical terminology here. So I'm going to expand first. That's using the distributive rule. Expand is just multiplying out any brackets that are here. So 2 times 3x is 6x. 2 times minus 1 is minus 2. And now I'm going to do 3 times 5 is 15, and 3 times x is 3x. But what's the sign here with the 3x? Minus. Why is it minus? Okay, yeah, that's one way of looking at it. Yeah, it's 3 negative x's. So that's another way of looking at it. There's nothing to change the sign here. There's just add 3 negative x's, and if I add 3 negative x's, that's negative 3x as an absolute value of it. Okay. What do I do next here? Yeah, combine any like terms that are there. 6x take away 3x gives me 3x. And I have a negative 2 add 15. Of course, we can read that the other way. 15 take away 2 is 13. Can I go any further? Is that 16x or anything like that? No. Okay. Let's do the second one. We have x times 2x minus 1. And we have minus 2x times 5 minus x. Okay, lots of x's here. Let's apply this x in. X times 2x gives 3x, yeah? No, 2x squared, yeah. Just keeping you, see if you're awake. X times the negative 1 gives negative 1x, or just write negative x. 2x times the 5 gives negative 10x, I think. And then we have this final multiplication. What's it? Minus 2x squared? plus 2x squared. The plus comes from this double negative multiplication. If we go back to year 7, a minus times a minus is a plus, as Jay was saying earlier on. Minus times a positive is a minus. So a minus times a minus gives a positive, and 2x times x gives 2x squared. Okay, just be careful. Anytime you're multiplying by a negative, it's going to affect the signs inside the bracket. So this 5 became a negative 10, and this negative x became a positive. And then I can combine any like terms. 2x squared, 4x squared. Negative 10x, take away another x, is negative 11x. Okay. What about if I have two brackets that are stuck together, like in the third example there? If we have two brackets, they're stuck together, a brackets times a brackets, like this. What do we have to do here? Ethan?
Is it the x in the first bracket times the whole bracket and then the 3 times the whole bracket, so like x squared plus 2x?
Yeah. Exactly right. So the x and the 3 are grouped together here. They have both got to be distributed through this. So the x has got to be, and the 3 has got to be. So there's a couple of ways you can write this. If you want, you can split this up and say, well, the x has got to be multiplied by this, and the plus 3 has got to be multiplied by that. So the x and the plus 3 you can split it up and make it look like this if you want. Most people probably don't split it up. You just look at it and can multiply it looking at it. I'm going to say it right. This has got to be multiplied by that by that, this by this, and this by this. So 4 multiplications. Some people call it a FOIL method. I don't know. Anyone see that before? No. X times, so I need to do this times this gives x squared. This times this gives plus 2x. So that's the x dealt with. Now I'm going to do the 3 times the x, 3x, and the 3 times the 2 to give 6. So there's 4 multiplications. I can combine any like terms, x squared, and then there's a 5x here, I think, these two combined, and a plus 6. Okay? I would have got the same answer had I done it this way. This way is just a little bit quicker. It skips a line. You would have done this before. A little nod if you've seen something before. Maybe not. Okay. I'm going to do one more example, and then you're going to get stuck into them. What type of equation is this called? Say you know the name, special type of equation. An x squared, an x, and a constant. Ethan?
I don't know.
Begins with a Q. U, A, quadratic equation. Yes, it's a quadratic equation. Okay. All right, we'll be coming to those. All right, let's look at one more example. So we got 3x plus 1 squared. Quadratic, never heard of it before? Yeah. Don't worry, we'll be doing it. I just thought it might have been touched on in year 9, but not. Okay. 3x plus 1 to be squared. That's just 9x squared plus 1, yeah? What do we think? Yeah. So 9x squared plus 1? 1 squared is 1? Is that it? Miles? Yes, that'll give the 9x squared. Miles is absolutely correct. Don't make the mistake of 9x squared plus 1 because there's going to be some middle terms here. Squaring something is multiplying it by itself. 3x plus 1 times 3x plus 1, as Miles says. So it times itself looks a bit like this now. So there's going to be 4 terms in the multiplication. 3x times 3x gives 9x squared. So that's the first one times the first one, the other one. The first one times the second one. 3x times 1 is just a 3x. These two middle terms next, the 1 now I'm multiplying by gives another 3x, and the 1 times the 1 gives 1 squared, 1. And now combine these middle two, which will always combine, and we get another quadratic equation. Okay. We don't need to solve anything today. We're just expanding using the distributive rule and collecting like terms if possible. If you can add something together, always add something together. Okay, you guys can do some now, just underneath where you finished the last thing. Oh, that's shaky. Oh, it's small. Okay, if you can do a minimum of 5 parts from each question, whichever 5 parts you would like to do. Usually the ones towards the end of the question are more difficult than the ones at the start of the question. Just do 5 parts. Up to you which 5. I'll give the answers for all of them in about 10 minutes. Any 5 parts you want.